All right, ladies and gentlemen, I apologize. It's a little late. I did not get home in a very decent hour tonight. So we're going to go ahead and, like I said, for my seventh grade classes, we're going to go through lesson 8 and lesson 9 tonight because these two lessons are pretty much identical to each other, and it gives us an opportunity to catch up a little bit because we are a few lessons behind, and it's not a very beneficial thing for us to be at this moment. All right, so classwork. Well, actually, let's look at the lesson title real quick. So we're applying the properties of operations to add and subtract rational numbers. Okay. So example 1 says the opposite of a sum is the sum of its opposites. Okay. Well, I'm sitting here and I'm thinking to myself, okay, so we got to use a specific math example. So when is the sum of two rational numbers going to give me the opposite of that sum, but then the opposite of that sum, okay? So the opposite of a sum is the sum of its opposites. Okay? So explain the meaning of the opposite of a sum is the sum of its opposites. Okay? So the sum of the opposite of the sum, and that means the sum of its opposites. All right, so we're going to explain this in a way that makes things a little easier. So the meaning of the opposite of a sum is the sum of its opposites. So we're going to use a specific math example. So the first thing that I like to play with is fun numbers, okay? So I'm thinking 12 and 8, okay? Well, 12 plus 8, that sum is 20, okay? Well, the opposite of 20 is a negative 20, okay? Now, that's the opposite of a sum. Now, that opposite of a sum is equal to the sum of its opposites. Okay? So that means my goal is here is to make sure that I get a negative 20 as the answer here when I get the opposites of a positive 12 and a positive 8. Well, the opposite of a positive 12 is a negative 12, and the opposite of a positive 8 is a negative 8. Well, a negative 12 plus a negative 8 does equal a negative 20. Okay? So the statement is true. The opposite of a sum is the sum of its opposites. Okay? That statement is true. That is correct. Okay? Now, I want you to do the same thing. I want you to practice. I want you to think about another example could you use. Could you use 4 and 6 gives me 10, and that opposite is a negative 10. So could the sum of a negative 4 and a negative 6 equal a negative 10? Looks like it checks out to me. All right. So the mathematical sentence is proven. We've got multiple examples that state that the opposite of a sum is the sum of its opposites. Okay. So that's something for us to important to remember because this is the property of the additive inverse. All right. Additive inverses state that that two numbers that are opposite of each other gives us a sum of 0. Well, that means also that two numbers that give the additive inverses result in the exact same sum when given the sum of an opposite. All right. All right, so let's practice a couple examples here. So represent the following expression with a single rational number. Okay, so we're dealing with fractions again. Okay, so when you are dealing with fractions, addition or subtraction, remember the denominator has to be the same. Okay, that is a priority. The denominator has to be the same when we are adding or subtracting fractions. Now, the first thing I'm going to do is I'm going to use the commutative property here. All right, I'm going to use the commutative property to help me out here because I want to rearrange this to where this number and this number are together. So I'm going to say it's a negative 2 and 2/5 plus, well, my 2/5 kind of looks a little goofy there. Negative 2 and 2/5 plus, or well, I guess in this case, minus 3/5 plus 3 and 1/4. All right, now that everything's together, I want to show you something interesting about all this, okay? This is going to get very interesting, okay? So I want you to look at this. A negative 2 and 2/5. Can we say that a negative 2 and 2/5 is equal to a negative 2 plus a negative 2/5? Would that not give me that same answer? It does. So because of that, I learned something very interesting here. I can separate my mixed numbers into a whole number and a fraction. Well, that's very interesting. So you're telling me that I could write this as a negative 2 plus a negative 2/5 plus a negative 3/5 plus 3 plus 1/4? I can rewrite that whole thing as one giant addition problem? Dude, that is awesome. If I can do that, then I can make some simple adjustments here and see if I can't get myself an easier answer than what I was originally planning on doing. Well, a negative 2/5 and a negative 3/5. Okay, if I added those together, it would be a negative 5/5, which is the same as saying 1, right? A negative 1. So instead of writing a negative 5/5, I can write a negative 1. So now I got a negative 2 plus a negative 1 plus 3 plus 1/4. Okay. Well, now a negative 2 plus a negative 1 is a negative 3 plus 3 plus 1/4. Oh my God, look right here. A negative 3 and a positive 3. Those are opposites. Opposites mean those values equal 0. So they go bye-bye, which means the only number left is a positive 1/4. That's my answer. A positive 1/4. Now I know what you're thinking. Oh my God, Mr. Hale, how on God's green earth did you do all that? How'd that all work out? Well, let's try another problem and see if we can do the same thing again. So I'm on S44 now in my book, so I'm going to turn the page to S45. Okay. Oh, wow, look. Example 2. A mixed number is a sum. Wow. I didn't know I was doing that. I took a mixed number and I wrote it as a sum of two numbers. So using a number line model below to explain and write the opposite of 2 and 2/5 as a sum of two rational numbers. Well, the opposite of 2 and 2/5 is a negative 2 and 2/5. So if this is 2 and 2/5, this is a negative 2 and 2/5, which means this value is a negative 2, just like this one is, and this would be a negative 2/5, just like this one. So let's get a little bit of practice on this, because this is fascinating. If we can take two numbers out of a mixed number, oh, that's going to be a game changer. So let's see here. I got a negative 9 and 5/8. Well, if I can rewrite this as a sum of two signed numbers, well, let's see. The whole value is negative. So that should mean both numbers are going to be negative if I split it apart. So it should be a negative 9 plus a negative 5/8. Now, if I plug that back into a calculator, I bet you $20 I would get a negative 9 and 5/8. Okay? So all you're doing is taking the whole number, the fraction, separating them into an addition problem, and whatever the original sign was, both fractions get that, or both numbers get that sign. So like for example, in C, this is a positive number. So that means if I take these two and break them in half, I get 8 and 11/12. I'm looking to do a sum, so it's an addition problem. And since they're both originally positive, they both stay positive. Okay? Interesting, right? Do B for me tonight. I want you to tell me what you would get if you broke those two up. Okay? Let's look at exercise 3. Represent each sum as a mixed number. So now we're taking them from apart from each other and we're making them whole again. Okay, so let's look at A. Now remember, when we looked at A up here, all right, both numbers were negative. So because they were both negative, we knew that the original value was negative as well. So now we got both values here as being negative again, which means my answer should be negative as well. So now all I'm doing is taking this value with this value and bringing them back together as a family. So -1 and 5/12. All right, look at B. 30 plus 1/8. They're both positive, just like C, where both were positive. And then I look at C's original problem was 8 and 11/12. So I'm taking these two pieces and bringing them back together. So I'm going to do the same thing here. I'm going to take these two pieces and I'm going to bring them back together as 30 and 1/8. 30 and 1/8. Okay, I want you to do C tonight. All right, and I'm going to pull that up real quick. Switch to something. All right, so we're going to change the page again. We're going to go to S46. Okay. Tonight, I want you to do exercise 5 on your own. Yes, it's a lot of work. Okay. It's going to be homework, but we are going to discuss together. This is going to be our together problem tomorrow. Okay. So just give it a try. See what you get. Okay. And then we'll come back and we'll discuss it tomorrow. All right. That's on page S46 in my book. So probably somewhere around S50 in your guys's. All right. So tonight in the problem set, okay, this is what I want you to do. All right. So I've already given you 3 problems to work on. I want you to do 1A. I want you to do 1C. All right. I want you to do... I want you to try number 3 and number 4. And then I want you to do number 6. Okay. Just a couple quick problems. All right. That's from lesson 8. So let's move on to lesson 9. See, now look at the title of lesson 9. Applying the properties of operations to add and subtract rational numbers. Sounds quite familiar, doesn't it? Because it is. Lesson 8 and lesson 9 have the exact same title. So that means we're going to work on lesson 8 and lesson 9 together. All right, so exercise 1 says unscramble the cards, all right, and show the steps in the correct order to arrive at the solution of 5 2/9 minus 8 1/10 plus 5 2/9. Okay? All right, now, we obviously can't unscramble the cards. Okay? But what I can do is I can start looking at the problems. Okay? So I start looking around here, okay? Let's see, I got this one here. Got this one here. I got this one here. All have parentheses. Now, what I do notice is that I've gone from a subtraction problem here to addition in all 3 of these. So which one looks most like this one, but now has an addition problem instead? Well, this one still has 8 1/10 in the same place and a negative 5 2/9 in the same place. The only difference is that these are now negative where these were positive. I wonder if they use the subtraction rule here. So if they use the subtraction rule, that would be the first step. Okay, so now the next thing is which one looks most similar like this, but only has a couple of changes. So we start looking. I still have 5 2/9 here, but this one has parentheses around the 5 2/9. I don't think that's going to be the next step. I think I'm going to stick with this one down here because it still has 5 2/9, but only these 2 numbers have changed position. Oh, they use the commutative property of addition to switch places. Oh, that is amazing. So that's number 2. They use the commutative property there. Now, the next one is which one looks most closely like this one, and that means this has got to be this one up here. But what'd they do? Well, I'll be a monkey's uncle. They use the associative property of addition. They switched the groupings. Instead of negative 5 2/9 and a negative 8 1/10 together, they made sure the 5 2/9 positive and the negative 5 2/9 were together. Well, that is brilliant. Now, I know that 5 and 2/9 and a negative 5 and 2/9 are opposites of each other. And opposites give us a sum of 0. So that means this has got to be the next step, number 4, which means this was number 5. The solution was a negative 8 and 1/10. The answer was there the whole time. My gracious, that's amazing. Whoever did this did a fantastic job coming up with this problem, showing how to use the commutative property and the associative property and the additive inverse property to give us an answer. I think that's pretty fantastic. All right, so let's continue on here. So represent each of the following expressions as one rational number. Show and explain your steps. Okay, I like this problem. So the first thing I'm going to do is I'm going to use the distributive property, or no, I'm going to use, not the distributive property, the subtraction rule. Okay, I'm going to use the subtraction rule here because I want to take this negative, the subtraction sign, and change things. So I got 4 and 4/7. Now the subtraction turns into a positive. Everything inside of this becomes a opposite of itself. So the opposite of a positive 4 and 4/7 is now a negative 4 and 4/7, and the opposite of a negative 10 becomes a positive 10. Okay? Now, look at these two numbers right here. Those look like opposites of each other. So I wonder if I could use the associative property, all right, to regroup these two numbers. So instead of a negative 4 and 4/7 being with 10, we instead say 4 and 4/7 plus a negative 4 and 4/7 plus 10. Okay, so now I've got the additive inverse property that tells me these two values equal 0 plus 10, and my answer would be 10. All right, you see how I wrote down every step? I did the subtraction rule, I did the associative property, I said the additive property, the additive inverse property, to show what was happening in every step. I want you to do that for number 2. Okay? All right, and we are going to do exercise 2 in class, all right, but it's going to be a you do with group, okay? I want y'all to work with this in a group, so I'm going to assign you some groups tomorrow, and I want you to work on it, okay? All right, and with that, we're going to save 1, 3, and 4 for classwork tomorrow. So be prepared, okay? And that's the end of the lesson. You're done with lessons 8 and 9, and I will see you all bright and early tomorrow. I expect you to have watched this video. I expect for you to be awesome and be able to tell me everything we've been working on in this lesson. I expect for you to be prepared. I expect for you to give me A+ work. I expect you to be phenomenal. I want your best. So be prepared to give it to me tomorrow, please.